So now, let's deal with this question. So let me just rewrite it over here to prove that it's equals to sine A plus sine B, right? So let's go for it. Obviously, we're going to choose the left hand side. So let's choose the left hand side. All right. So now, um, when you look at this, this is a double angle, right? So notice that sine 2 theta is actually equals to 2 sine theta cos theta, right? So this is a double angle. So it means if we see 2 sine something cos something, it's a double angle. However, we've got a slight problem. The problem that we have is that this is a minus and it's on a plus, right? So meaning that they are not the same. All right. However, we can do something, right? We still can do something. So number one, we literally cannot reverse them because the angles are not the same. Notice sine 2 theta is 2 sine theta cos theta, but these angles are not the same. So the funny part is we literally cannot use double angles. All right, wonderful. So now what can we do? I'm literally doing this in real time. So I'm just showing you my thought process. Okay, fine. So now there's something we can do here. We can use compound angles because we can literally split this. So we literally have no choice but to use compound angles. Here's something we can do. A plus B is the same as A plus B over 2 rather is the same as A over 2 plus B over 2, right? Because when you're adding fractions and they've got the same denominator, you usually keep the denominator and just add the numerator, right? That is the basics of adding fractions. So we're going to do the same thing here. It's going to be A minus B over 2 and B um, rather yeah a over 2 and minus b over 2, right? So let me just write this a little bit better. So let's just write it a little bit better. So now we're going to have to expand both of them using the rules of compound angles. So let's do that. So we know that sine is sine cos cosine, so it's going to be sine, so sine a over 2 cos b yeah cos b over 2. So let me just try and write it a bit better. I wonder what's happening with this device. I don't know why is it doing this. Okay, so we're going to have this stuff. All right, so now we're going to have, so this sine cos, then the sine stays the same, right? As for same, so the sine stays the same, so it's going to be plus cos sine, right? So we're going to have cos a over 2 sine b over 2. All right, so now this is literally going to be multiplied by the other one. So when you expand this, cos is cos, cos, sine, sine. So we're going to have cos a over 2. So let's just do this. So cos a over 2, and then we're going to have cos b over 2. Then we're going to say minus, let me just write it over here. So yeah, let me just write it over there. Matter of fact, let me just rewrite this stuff. So let's just rewrite it. Alright, so I wanted to create more space so that we can be able to see some certain patterns. Okay, um, so after this part, because cos C for change, so the sign changes. So if it's minus, it's going to be plus. If it's plus, it's going to be minus. So it's a plus. So this is actually a plus. But anyways, let's just ignore the previous line. So then we're going to have, so cos is cos, cos, sine, sine. So this is going to be sine A over 2, sine B over 2. Alright, great. So let me just delete the previous line. Alright, so now I want you to be able to see a certain pattern. Okay, fine. I expected a certain pattern. Okay, fine. There is literally no pattern. One of the patterns that we should expect is if we see something like this, for instance, then you know that you don't have to waste time distributing. The answer is literally going to be a squared minus b squared, because if they ask you to factorize this, you'd put it in this form. So if this was exactly the same as this and this was exactly the same as that, and on one of them we had a plus, on the other one with a minus, we're just going to write the answer as the square of this whole thing minus the square of this whole thing, right? Just like if we have this, our answer is just the square of this whole thing, which is here, minus the square of this whole thing, which is here. But now here there is no pattern, right? So we literally have no choice but to literally multiply. We're literally going to have to multiply this stuff because we see no similarities.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you are studying NSC, which is the South African curriculum, or IEP, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
If you're interested in knowing the prices, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So let's just multiply. So I'm still going to have 2 outside, so it's just going to be 2 times. So we're going to have a bigger bracket. So this times this stuff is literally going to be sine A over 2. So let me just write it as sine A over 2 cos A over 2. I'm just choosing to put the angles together, right? So sine and cos. You can literally write it, but anyway, there is literally no problem. So cos B over 2, cos B over 2. Okay, so cos B over 2. Okay, let's just do this. So we have sine A over 2, cos B over cos A over 2, then we've got cos B over 2, cos B over 2. So eventually, here, why am I writing cos B over 2 and cos B over 2? We can literally just write cos squared B over 2. So this is going to be cos squared B over 2 because they are literally the same, right? This is going to multiply that. So at least we can kind of shorten the writing. Okay, so now we're going to multiply this and the last term. So now notice that if we multiply this stuff, a over sine over 2 this time appears twice. So I'm going to say sine squared. Okay, so we're going to say sine squared a over 2. And then now this side we're going to have cos b over 2 and sine b over 2. Let me just write it in this order. So sine b over 2, cos b over 2. Because who knows, it might benefit me. So I'm not yet sure what will happen, but let's just write it like this. So now this is going to be, and now when you multiply this one, we have cos a over 2 and cos a over 2 twice. So we're going to have cos squared a over 2. So we have cos squared a over 2. And then this side we've got sine b over 2 and cos b over 2. So let me just write sine b over 2, cos b over 2. So sine b over 2. And then hopefully there's some space. Then we've got cos b over 2. Alright, so now we have to multiply the last one, right? So now we have to multiply this one. So let's multiply this one. So this is going to be cos a over 2 and sine a over 2. So let me just write sine a over 2. So let's just do that. Sine a over 2 cos a over 2. So we're going to have that. And then we're going to have sine b over 2 twice. So it's going to be sine squared b over 2. So sine squared b over 2. All right, great. So now let's see if there are any like terms. We see that these are exactly the same, almost the same. So we've got sine a over 2 and cos a over 2. And then we've got this. Let me just see if there's anything similar. So if we have sine a over 2, cos a over 2, but ending with cos squared b over 2, do we have it anywhere? We literally don't have it anywhere. So it's as though we literally don't have a like term. So what can we do? All right, anyways, we're going to sort this out. So there's 2 ways that appear in my mind to solve. So let me use the first way. Let me use the first way because notice it will become a double angle if I distribute this to inside. So if I distribute to inside, I'm going to have 2 sine a over 2 and then cos a over 2. And then we're going to have cos squared b over 2. It's going to be a little bit weird the way this will be solved. So it's going to be, so let me see something, sine cos. Let me just choose to put this in front and this behind. So it's going to be 2 sine b over 2 cos b over 2. Okay, so it's going to be cos b over 2. And then we're going to have sine squared. So sine squared a over 2. Alright, great. And then now this side, we're going to, okay, so here it's going to be 2. So let's just write it in this order. 2 sine b over 2 cos b over 2. And then we're going to have cos squared a over 2. Okay, let me just try and write it a little bit better. Okay, great. So now we have to multiply also the last term. So I just distributed the 2 in the bracket. So then here we've got 2 sine a over 2 cos a over 2. And then this is sine squared b over 2. All right, wonderful. So this is the next question. So now notice that this particular portion is double angles, right? So because if we have got 2 sine theta, right, 2 sine whatever and cos whatever, it's going to be equals to sine k. It's going to be equals to sine 2 times whatever, right? So it's an identity. Sine 2 theta is 2 sine theta cos theta. So if we've got 2 sine something cos something, we're going to have sine 2 times that thing. So we're going to do the same thing. So we have 2 sine something cos something. So it's just going to be sine 2 times that thing. So notice this will be easily simplified. So let's just do this for now. So we're going to have, and then here the same thing is going to be sine 2 of that thing, right? So sine 2 times that thing. So we're going to have that, and then we're going to have 2 sine squared a over 2. All right. So this is what we have so far. All right. So now here, let's just continue. Let's just do this. So here we have another double angle. So it's just going to be sine 2 of that thing, b over 2. So we have b over 2. So then here we're going to literally have cos squared a over 2. Okay, so let's deal with the last one. So here we've got double angles. So this is going to be sine 2 of a over 2. And then we're going to have sine squared b over 2. So there are things we can do here. So notice that, okay, fine. Before that, let's just simplify it to the simplest form. So notice what's going to happen here. This 2 will cancel that 2, right? Because 2 times 1 over 2, notice they cancel, right? So when one thing is up and the other one is down, they cancel, right? So this is the same as 2 over 1. So now when it cancels, it's going to be sine A, and then we're going to have cos squared B. So cos squared B over 2. So cos squared B over 2. So this is what we're going to have, and then this is what we're going to have sine B, and then we're going to have cos squared rather. So what am I doing? Sine squared. So it's going to be sine squared A over 2. Of what? Wonderful. And then this is going to be, okay, fine. So I just got distracted by something. So this is going to be sine B. Then here we're going to have cos squared A over 2. So now we've got space to add this. Yep, literally we've got space. So this particular portion is going to be sine A. So it's going to be sine A because the 2's cancel, and then we're going to have sine squared b over 2. So we're going to have sine squared b over 2. All right, wonderful. So now let me show you something over here. All right, so now let's work this out. So this is going to be, okay, fine. So now notice something. I want to group things that are kind of similar. So we've got sine A here. I'm going to show you something. I just have to choose something. Let me see if there is another cos squared b over 2. Well, there isn't cos squared b over 2. So I have to use the first thing that I was thinking about. Okay, so we have to look for another thing that has got sine A. So another one that is sine A is the one at the end. So let me shift it here. I'm going to show you why am I doing this. So this is going to be sine A. Then we're going to have cos squared b over 2. And then we're going to have plus sine A, right? We're going to have sine A. Then this side we're going to, so this is sine squared b over 2, right? So remember, I'm just shifting it to the second position. So this is going to be sine squared b over 2. Okay, let's just do this. So sine squared b over 2. So now this one's already grouped. So let's just, because it's sine b and sine b. So we're going to have sine b and sine squared A over 2. And then this side we're going to have sine B, and then cos squared A over 2. Wonderful. So now, why did I group them like this? The reason why is because we can factorize this part literally. Notice what's going to happen if we factorize this part. So if I factorize this part, I'm literally going to have cos squared B over 2 plus sine squared B over 2. Notice something. Sine squared plus cos squared is 1, or even cos squared plus sine squared, forgive my handwriting there, is also equals to 1, right? So notice, this is cos squared theta plus sine squared theta, right? I just take B over 2 as theta. So, um, so this is going to be 1, right? So same thing that will happen here. So we have to show them all the steps. So if I factorize sine B rather, in the bracket I'm going to have sine squared A over 2 plus cos squared A over 2. So notice what will happen. We're literally done because this is going to become 1. So it's just going to be sine A times 1. Let me just write it just for the sake of writing. We can skip this step, but let's just write it. Then there's going to be sine B, and then this part gives us 1. So it's also going to be 1. So that is it. Sine A times 1 is sine A. And then sine B times 1 is sine B. And we are done.